Hello and welcome to this presentation. My name is Engineer Isaac Friday. In this video, you are going to learn how to model this steel bridge, load it, analyze, and design all of the structural members of this steel bridge successfully in this video. And so, you have to stick to the video and pay close attention for a better understanding of this complex modeling successfully. Once again, you are welcome and let us get started. We want to look at the parameters and the dimensions of the setting out of the steel bridge successfully. So I will navigate to the plan view, and then you can now see the setting out of the reinforced concrete columns and the foundations, okay, of this bridge. So we have 1 meters spacing right here, okay. The bridge apart is 8 meters, alright. Then the total length there is 12 meters in the length aspect of it, and then in the width aspect of it we have the total to be 6 meters, which we have 1 meters, 1.4, 1.2, 1.4 and 1 meter, alright, successfully. So this bridge is meant to be constructed on land and not across a lake or a creek, okay. So we want to make progress into the modeling of this steel bridge successfully, okay. And also we are using Protastructure 2022 version, as you can see, right. So for us to start the modeling, we need to create a new project, okay. So we will click on the file menu right here and then navigate to new project. So this will open up a new project because you can see steel bridge x1, okay. So I will change that x1 to steel bridge 5, okay, just like this. I'll scroll down. I will be considering United Kingdom BS8010 for this modeling, okay, for the sake of the presentation. Click on OK options, and this will open up a template BS8010, so we can start the modeling aspect of the bridge successfully. Alright, so here the template is ready. I want to get to the building setup tab, and then you can navigate to the axis, okay, at the modeling tab rather, to the orthogonal axis. Click right there. You can pick any point in the scene environment, okay. So to have the orthogonal axis generator, okay, just as I used to say in most of the video, okay, I did on my channel, you notice the axis level A is the horizontal axis, okay. So for the axis level A, what we're going to have, because this is the horizontal axis, or the horizontal grid lines. Grid line consists of the vertical, okay, vertical grid lines, and then the horizontal grid lines, okay. So here we will have 1 meter, all right, just like this, and then we'll have comma. What we'll have next is 1,400, have comma. Have next is 1,200, have comma, and then we will now have 1,400 again, like this, we'll have comma, and then we'll have 1 meters, okay. So these are in millimeters, all right. So 1 meters is equals to 1,000 millimeters, okay. So we make progress in the direction to what we need to have. Also, we are going to be having, okay, so we are going to be having 1 meters right there. We'll have another 1 meters. So the space between the bridge, okay, is going to be 1,000 millimeters or 8 meters. We have comma right there, and we still have another 1 meters followed by the next 1 meters, just like this, okay. So we haven't gotten this. Just click on the OK option, and then you have this set out grid lines, just like this, okay. So you can now see we have total of 6,000, we have total of 12,000 this other way, okay. After which the next point is for us to generate stories, okay. We have to generate stories, and as well set our story height, okay. So we have up to 4 stories, so we have to select stories right there and click on the insert stories, okay. In these provisions we have 4 stories, all right. So you can see story height at default is 3 meters. We'll edit this later, okay. Click on the OK option, yes, options. So let's edit the stories, select the stories right here. Mind you, you can also get this options through pass through the building set out, and then come to the stories operation, so you can see the same options. Okay, right? So we'll proceed and then click on the edit stories. So for the sake of the presentations, my story one is this going to be 450. So 450 in the sense that this is just like a normal 450 to the normal ground level. Okay, so my story 2 is going to be 1500. Okay, the first rest, okay, landing before you take up to this story. So to take up to this story should be like 2200. Okay, right, 2200, while these other stories we can't go by 2500 right there, or 2600. Okay, so this is the story set out. All right, then the structural systems at the foundation level, which is from story 1, is going to be ROC. Okay, so then from story 2 to story 4 is going to be steel right there, just like this. Okay, so the depth of the foundations in your calculations, you have to put this as part of the foundation depth, the 450 millimeters. All right, so right here 1100 millimeters as default foundation depth for that structure. Okay, then if you had this 1100 plus 450, you'll be having 1550. Okay, as the foundation depth for that structure successfully. For now, we will go by this successfully. Click on the OK options. Alright, so we'll start to place the pedestal, okay, by double clicking on the story 1. So here is the story 1. Okay, so let me navigate to the 3D so you can be able to see the difference between story 1 and the story 0 right there. Okay, but by then, to show you that clearly, you will need to be at the we will need to have some structural elements right here. So let's go back to the plan view. Right, so here we go. Now we get to the modeling tab. Okay, select the columns right there. So in the column dialog, we will be setting the column sections. Okay, we have it to be 450 by 450. Okay, we are going to try this actually. Okay, if it can be able to carry the bridge successfully. So now the first thing we'll place the columns right here. Okay, the first columns, we have another columns right here. So we have it as well here, and here we also have it here. Right, we just place this at random. We may correct this as we proceed. Okay, so we also have one here. We have another one just like this. Okay, so now this grid lines, this is the walkway. Okay, so be able to access this other landing of this bridge. Okay, this space between grid line D and C, while our landing as you goes up is the grid line E and F. Alright, over to this side. Okay, to this other side is A and B is the landing successfully. Okay, so having placed this successfully, we will proceed to place our reinforced concrete member, but by then let us navigate to the 3D so you can now see what we are having here. Alright, so we have this. So if you double click now on the story 0, you can now see this. So here is the 450. Okay, so 450 from the top of this pedestal to where the grid line is, and then from the grid line to the foundation depth, you have it to be 1.1 meters. Okay, so we make progress. Then let's navigate to that story 4 right there, where we're placing stanchions. Okay, so altogether, what should be the height of these stories? To know the height of the stories altogether, let's see it also here. This is 6.75, story 4 6.75. So we have extensions that will cut through up to 6.75. Okay, this is the extension, so there's no problem with that. Okay, so we will get to the modeling tab. So you get to the column, but by then you have to navigate to the plan view right there. So you pick the column right there, come to the sections manager. We will be selecting the small sections. Okay, so we are going to use UB in this case, and then we use this one, 202, 102, 23 millimeter tips. Get that selected, and then we will have it being rotate, okay, 90-degree angle, okay, and then we are to have it here at this point. But by then, here we'll have to key in 3 right here, 3 right here. Because update, why I'm keying in 3 right there is because I wanted to connect all the stories, okay. It is a story 4, okay, so you key in 3, so you connect all the story. Click on update. All right, so once click on update, I start to place it right here. So we have that, have this, and then we have this, okay, successfully. So the next thing is to place the stanchions over to this provision successfully, okay. So let's check what we have done to ensure it is correct, okay. So it's supposed to sit on top of this. You can see sit directly on top of the pedestal. So this is what we have done so far. Right, so we make progress. Okay, so now you have to navigate to the story 2. This is where we have the first landing platform for this bridge. So you navigate as well to the beam provisions. So we'll be picking a beams right there, UB, and so we used 152, okay, 89 and 16 millimeters. We on okay right there, and then we want to connect this successfully. So while connecting this, you have to be careful that you are picking the green line intersections to place this successfully. Right, so here is it. Okay, we are done with this. So over to this side. We will connect this as well. Okay, right, after which we would navigate to the next story, which is story 3. Okay, so at this story, this is where you can be able to now access the bridge, okay, access this other part of the bridge successfully. So we are going to be using this property, or we can also get back to the beams right there. Okay, so confirm the sections successfully. Okay, 152, okay, option, and then right, so that is done. Okay, we will get to the next story, okay, which is the top story. Okay, so you have to close this, navigate to the story 4. So at this story now, we will still get to the structural members, and we insert these beams successfully. So at this story now, we need to have a coverage. Okay, coverage in the sense that we have to have a cantilever beam right here, or have another cantilever beam right here, and connect it right there. Okay, so we have something of this kind. All right, so here we go over to this other side. We have to also have this. All right, just like this. Okay, so let's proceed. As well, you can join our ongoing training program if you have the interest to join. There's a link in the description of this video. You can just be able to reach us through the link successfully for the ongoing master training program for Protastructure successfully. Alright, so here we go. We have this. So the next thing we will be looking at, you notice we are supposed to have stair. Now this, to connect this, successfully. Alright, so we will proceed to the foundation, so we can start to model the access stairway. Okay, so we have to now navigate to the story 1. Okay, at this story we need to move these columns to this point. Okay, grid line 2 from grid line 3, so you right click and then can select move. Okay, pick there, so you pick the point you want to move. Sorry, right click again, pick on move and then take it to this grid line, just like this. Okay, so the same thing we'll be doing here. Okay, we move this to that point, so select it. Okay, and then you right click, can now pick move right here to this grid line successfully. Alright, so having gotten this, we will be connecting an incline member, steel members to form the stringer. Okay, but before then, let's do the same thing here. We're supposed to move these columns to this point. Alright, and over here, move this one. Sorry, move, pick these grid lines intersections. Alright, so we still get to the beams. Okay, this time around, let's check the sections. We use this one, 178, 102, 19 thickness. Select that. Okay, so we picked the first point and connect it to. Okay, escape that, close this first and navigate to the story 2 right there. That story. Okay, then get back to the beams again. We will be using. Okay, that is it. Select okay, and then you make sure you pick the relay intersection right there. Take it down. We have something like this. Okay, for this first stringer, make sure you zoom closely and be able to pick the grid line intersections. The reason for the grid line intersections is for you to be able to get a good analysis result without errors. Okay, alright. Okay, so having gotten that, over to this side, we need to do the same thing here. Okay, so if you have any question, you can as well drop it in the comment section. Alright, so having gotten this first, the next thing we'll do, we'll have to navigate to this level so as to model the steel member at that level completely. So at level 3, right here, we'll be having steel member. This, just use this property. Okay, we use this property, so we have escape that from that point to this point, and then from this point all the way here. Okay, so we'll be having a member here, after which we'll have another members that connects this point. Then we'll have another member so make sure, okay, it's at the grid line intersections. Okay, just like this. Okay, so we have something of this kind. Okay, so having gotten this, the next thing you have to do is we need to actually brace this. Okay, so we get to the modeling tab, but before then, save this project. press this right away, we'll be using the same members. This one, select it, right click the property. So we pick it from that point all the way to this point of intersection. It's not really giving us the exact point that you are supposed to place it, so you have to update this in a way that you can actually be able to view it correctly. So let's navigate the green lines to the story 2 right there. At the story 2, get back to the beams, check the sections is correct, select that, okay, then pick it right there, take it all the way to this point, place that. Okay, so you can see some warning right there. Okay, that's it. Current story 2, but ends of this beam is above the current story. Right, so click on yes options. So you will now have this. Okay, so this is just what we intended. Okay, so proceed, pick that point. Okay, this is warning, it's trying to tell you you are inclining this beam. Yes option. Right. Okay, so having done this successfully, we proceed to this other side. Before then, you have to navigate to that story 2. So select the structural members. Well, you can be able to mirror all of this to this other side. Okay, you can be able to mirror that. Alright, but for us to be sure of our modeling system, our modeling is correct, I will advise you do it. You do it individually instead of modeling a group. Okay, do it individually just like this. Okay, so we will be having a member here, and we will have another member like this here. Okay, so for this site, when we use this member, select it, right click and click on properties, pick that point all the way. We may not be able to get it like this, so close this and move the green lines to the story 2 right there, just like this, and then we use the same member, its property. So now we can be able to select the green line intersection successfully, and then all the way to this point of intersections. Yes options, have that successfully, and then from this side, pick that point. Yes options. Okay, so you can see what we have here, right? So having gotten this now, we'll come over to this side to do the same thing. Alright, so the same thing is applicable to this other side. So we proceed to the next stage. So the next stage we will be considering the reinforced concrete slabs right here. Okay, so we are going to be using ROC slab to actually transfer the U-mounts load to the beams, steel beams members successfully. So for you to do that, we are at level 2, so you just have to navigate to the plan view. This plan view, you have this. Okay, so select reinforced concrete slabs. Yes options. So we have to generate the loading successfully. Click on OK, and then now the slab dialog will be using 150 millimeters slab thickness with a cover of 25 millimeters. Okay, for an additional load, there is not much additional load, but we will use 1.5 additional loads. Okay, and then for the imposed load, right, we will consider 3 kilonewton per square meters right here. So we have to place that here to have the reinforced concrete slab right here. So we placed another one here as well. At this level, we are okay. So we navigate to the next level, which is going to be level 3. Double click on the level 3. This level 3, we still navigate to the reinforced concrete slab 150, 1.5, and then we use 3 kilonewton per square meters, because here we have a slab here, and we have it. Sorry, this is supposed to be across, okay, not only dot provision, so we can get rid of that by deleting it. So we use this property. Alright, so I notice it is actually trying to text the grid line. So this is beam region selected. Okay, alright. So we can use another instruction option. So we can use pick point. We can pick that point. So there are various instruction options. Okay. So now change this back to beam region. Okay. So you have to actually decide you have your staircase, so you can place it correctly. So to do that, let's go to the 3D. But before then, we can't still get to the last floor, so we can't actually cover up this the sheet of the stairway successfully. Select the slab again. Right, so you have this successfully. Click on closed. Okay. When we are just using this, right, to actually send some loadings to the beams for design purpose. Okay, because at this level you may not necessarily have humans at this level. Okay, but we are actually using it to design the structural beam members, just as I said earlier, for the sake of unforeseen circumstances. Right, so we navigate to the story tree right here. So at the story tree, we select this, right click on property, and we have this. Okay, so when you land here, you have to follow this access stairway to land here, and then come over here. So here is Revit modeling the steel bridge beam system or truss system across. Okay, shortly we'll do that. So we'll also have to place the slabs as well here. Sorry, that is wrong. Supposed to put it here. So just make sure that great. So we'll delete that other one successfully. So we will also have it here and here, right? Same thing applicable to this provision and this. Okay, okay, this is showing me, okay, meaning you have to use another instruction option. So this time around, let's see how we use pick axis option. Okay, that options we need to pick axis B, right? See, it's showing here. All right, so pick axis 4, okay, axis A, and then axis 6, right, and B to place it. You can see it's being placed successfully. Click on closed. Okay, so at this point you can see the slab, okay, in an opaque option or format. You have to go to the building setup like there. Okay, click on the layers. So in the layers, you navigate to the slab options. See ash right there. So change this a bit to more darker color options, and then click on okay. So have it just like this. Okay, so you can see. Alright, so at this time we want to start to model the steel bridge members. Okay, the bridge between these two structure. Okay, so for us to get the bridge between these two structure, we are going to be considering truss system. Okay, I will show you how you do that shortly. But then we need to get rid of this slab. Okay, so delete that successfully, because when you go up you land here. Okay, so they are supposed to be closed right here. That provision is not supposed to be closed. Okay, and again we are supposed to have this in this other side. Okay, not in the same opposite side, like the way this one is. But now check very well, the access stair is not facing each other directly. All right, but this is facing each other directly. Okay, which is not what we're supposed to do. So select that beam. Select that beam. What you're going to do, you can as well mirror that beam to this other side. So get it selected, and then over here you can see mirror option, picked it, and then select the line 2, and then click on OK. So yes options. All right, this mirrored up, mirrored it up. Okay, up. So get rid of this, delete this first. Now navigate to the story story 2 right there, and this story, let's do that again. Select this. Okay, mirror it, green line 2. Okay, yes option. So have it here, you can now see. So get rid of this one this time around, just like this. Okay, so this is how it's supposed to be. Now take this, we're going to use this property, but by then you need to move the green lines to that story so that you can place it successfully. Click on there. All right, select these properties, and then we are not updating, we are using the view region. Okay, zoom closely, and then you can be able to place that successfully, just like that. Close this and get rid of this slab right there, so you have something of this kind. So this is what we actually intended successfully. Let's see. Alright, so having gotten this, we'll proceed. So here, as I said earlier, we'll be using the truss system to do this. The bridge that is going to connect these two structure successfully. So what we need to do, we navigate to the modeling tab. Before then, we have to save the project. So click on save to save the project, and then navigate to the modeling tab right there, and then you can see trust right there. Click on that. This is our first point of the trust. Take it all the way to this other point. Of the trust. Okay, so this will break up the trust system dialog just like this. So what we'll be using is this option. So pick that. So we'll be using this option, this one. Okay, so we want to start the configurations of this truss. At first, we will be looking at the profile of these truss systems. Okay, so for the profile and the span, we already having this span here to be 6. Okay, so we can make it we can make the spans to be, let's say, 12. We will have something of this kind. So the apex height is 2000, so we want it to be like, we want to make it 800 right there, something of this kind, right? Then we proceed. We needed to actually have another heel. We have a left heel height, we have a right heel height. Okay, so at the left heel height we have, we just did an offset of 500, so you can now see it right here. So okay, so the same thing at the right and left. Okay, the same offset, so you have something of this kind. Okay, so after which you will now have to navigate to the within it cantilever. Okay, so You scroll down and see delete first and last vertical. So you click here to get rid of this first and last vertical. Alright. So we have a system just like this. Okay. So the next thing we will have to do is that we can as well change this to 8, or we used 10 right there. Okay. Alright. So I think this is fine now. So having gotten this, we have to change the members. Now we get to the members provisions. So for the top card of that trust member, we are going to be using beam right there. So we will use this beam for the top card successfully. So we have to select that successfully. For the bottom card, where you can choose to either use beam or add all sections, but you have to use the strong material that can be able to withstand. So beam, I think beam is preferable. Okay, steel beams. Alright, so after having that selected, the former sections is 178, so use the same 178 right here. So for the diagonals, we are going to be looking at the tube system. Okay, circular hollow sections. Okay, so we will have to make use of this one at 8.9 and then 5mm thickness right there. Alright, so the same thing we'll be using for the vertical at 8.9, 5mm thickness. So get that selected, click on the OK option. Alright, for the horizontal, we have horizontal in this truss system actually. But well, let's get to general and see what we've done so far. So we have this, so you can now see what we have here, right here. So you can be able to update it to see that we are having something well modeled. Okay, you can now see it right there. Okay. Alright, so with this now, you can now click on the OK options. So click on the OK options, you have this. You see, so you can also place it to that side. Right click to get rid of this command successfully. So you have something of this kind. You see. So just a bit close to it to make sure everything is fine. Alright, okay, so everything is very fine. Okay. Now having modeled this successfully. So once you get onto the platform right here, you can just follow this path. Okay, you are following this curve path up to this other provision. So we need to have a kind of tensions members right here, tension members right here, where you have our plate, so as to provide a smooth walkthrough across this bridge successfully. Okay, so we need to have that. We also be using beams for steel beams for that successfully. So click on this steel beam right here. So we will use a beam sections, a smaller beam sections for that provisions. Okay, so we can choose to use this 152 or we use 127 for that. Okay, just a tension member. Okay, so it all depends on where you want to place that. Okay, so this is a warning. Click on yes options to have that. So this is far below. It is far below the top of the beam, so we are supposed to have it at the top right here. Yes option. Yeah, this is what I'm intended to do. So you have this. The first one we placed, we will have to change it right here. So you can actually get this right successfully. Okay, so if you want to be modeling a more complex structure of this kind, the Protastructure, I will advise you join our ongoing masterclass essential training program, Protastructure. So let's get rid of this particular beams right here. So we delete this up. Okay, so having deleted that up, we will need to connect this. You can use this members property just like this. pick that point and this point. Yes, options. Okay, we can also brace the bottom, but that is not necessary. Okay, it's not necessary. But if you like to brace the bottom as well, you can brace the bottom. Right, using the same property you have it right here. Look at the property. So this time around it's going to be center to center braces. Okay, this thing has, okay, we need to get rid of that. It's not model enough, so in as much as it's not model enough, we will proceed with that. So use that property again and then detect it from this point. We can also change this to maybe circular sections, since the beam may not be model enough. So you can use circular sections, the same circular sections, select that, and okay, so picked from that point to this point. Right, so let's check. You can see this is model. Okay, it's model to some extent, but we can reduce the sections, okay, to 76.1. Click on the update. So this is nice. Now you can see, right, so this is serving as a brace to the steel bridge member successfully. Alright, so here we go. Close this. The next thing is the gable cord on top of this bridge. Okay, the gable cord that will help the pedestals to actually walk comfortably and how we have to hold your hands. Okay, so for the gable cord, we have to navigate these grid lines to the other stories. We get the grid line to story 4 right here, so we can be able to model the gable cords right away. So now, how many panels do we have here? We have 10 panels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 panels in this truss. Okay, so we have to be calculative a little bit. Okay, but I'll show you what we do as we make progress. Click on this truss again. So pick this point right there all the way. You have to pick this point. Okay, so having done this, you will need to change the top cut. This top cut, we will change it to, the top cut members. So go to the members properties for the top cut, click right there, and then we change the circular hollow sections. So we are going to be having a smaller hollow sections diameter. Okay, so let's try diameter 42.4 and then 3.2 thickness. Right, so select that. Okay, successfully you have that. Okay, let's get back to the general as well. So at this point we are going to be inverting this truss. Okay, so invert truss option. So click on the options to have it inverted, just like this. Okay, so let's get back there again. Okay, so we have the top. Okay, we need to change the bottom as well. So this bottom as well to circular all sections 42 3.2. Select that successfully. Alright, so get back to general tab. So we have this. Okay, alright, so having gotten this, we need to move this whole stuff to the we will need to take this to the user defined trust. Okay, options. So what we have to do before then, we will need to do some little settings here, because any changes you make to this trusses, like user defined changes, you won't be able to access the geometry provisions. So what we need to do right away is where we have this left here. So let's work on these provisions. Have here to be 20. sorry, 200. I think this will be fine. This will be fine. Or we can make it 100, right? Okay, so having gotten this right, we can as well check the apex. Okay, the apex. Okay, so we want to make it more deeper. You can say 1000. So you see it's more deeper, right? Alright, so let's go to check it by clicking on OK options. Okay, so you have something of this kind first. Okay, you have something of this kind, so you have to check if this is good by you. Okay, and then you can see where it is from here. Alright, so we need to offset by taking this upward a bit. Alright, so what we'll do is and then about this we need also to get this upward as well. So select this again, come over to where you have the apex. Instead of that, let's use 600 right here. This will be fine. And then for the offset, we need to look at left vertical offset and right vertical offset. Okay, so let's have that to be 100 at first, and then 100 right here. Okay, let's click on OK to check that. So we have something of this kind. So you see what we have now. So you have to also check this to be sure that what you're having is what you intended actually. So zoom closely. So our consign is on this bottom. So make sure the bottom is actually in the position where you intended. Okay. So we will need to offset this. Okay. Double click on it. Come to the offsets left and right. This time around make it 200. Let's see what it gives us. Right, 200. Click on OK. Oh, this is off expectation. This is off expectation. Okay, so I just did to 150. Right, 150. Okay, so just like this. Click on OK. I think this should be fine now. This is fine. So we can go by this. The next thing you look at is the radius of this. What do we have? This radius is enough. It's okay. Alright, so now let's proceed to user define these properties. So we are having to user defined options. Click right there. So this will take you to this interface. So this interface we ought to get rid of some of these members right here. So you get rid of these members just like this. So you delete on the keyboard. Just delete on the keyboard to get rid of it. So you get a code just like this. Click on the OK options. So you have something of this kind successfully. Alright, so having gotten this time around, so you can select this and then use this property. Click on OK, and then we will need to save this. Okay, so just get to the property. You have this. Okay, and then you come over to general. So this is what you now have. What I said earlier, you wouldn't have any geometry provisions to edit right there. So what you need to do is to save to library. Okay, save this to library. Click on save. So just call it code. Okay, just call it. Let's call member. Alright, so click on save right there. Then click on OK. So if you want to do another truss system now, you can navigate to the modeling tab, pick the truss system. So you pick this first point all the way, pick the second point. So you still have this, click on OK to have it there right away. So we proceed. Now we have to connect some posts. Okay, that we actually links the cord with the trusses. Okay, so we use frame to do that. Select frame option. So in this frame options sections, we also use this. So we will consider this section we will use up there is 42.4, 32, can use lesser sections. We can't choose to use lesser sections. Okay, let's go by that. Alright, so just have to click on the top of that. Remember, all the way, click on that yes option. But placed successfully. You can see yes option. So alright. Okay, so can I see what we have here? Alright, so over to this side, we have to connect that to use this property as well. So for this model, you can also see a link to get the Protek file of this model. There's a link in the description of this video for the Protek file of this model. You can also get it downloaded successfully. Alright, so we are done with this model. So you can now see we run our model successfully. So for load this, you can actually add additional load if you wish, or use the slab loadings that you've done to carry out your analysis of these structural elements. So save the project first, after which to analyze this project, you proceed to set your soil bearing capacity, and then after which you get to the analysis, and then you can be able to carry out your building analysis after setting the materials as well. So let these materials to be a default, and then you get to the analysis tab right here. So you just have to click on the building analysis to start analyzing the structure successfully. So once you click on the analysis tab, this is what you have. So you can as well analyze first before you design, or you can design in the process of analysis. Okay, so click on build analysis right here. So you can see building analysis completed successfully. Would it have any warning? Would it have any error? So you can now say relative story draft satisfy the limit in both direction 1 and 2 successfully. So everything is good with this model that you have made successfully. Click on the OK options. And then you can close or decide to view the model, the analytical model, and the behavior due to loadings and stressed. Click on close options. Right, so this model has been analyzed successfully. So you want to check the columns right there. You can navigate to the story one. So this column has not been designed because we did not design. The structure will only analyze. So I click on it, click on the columns / wall design active stories. So alright, so you can now see that this has not been designed, but you can do that design using column design bash mode. So in this bash mode, you can select all the bars, click on calculate. Click on closed. So to have all of the column designed successfully, so you can see the stress on the columns is not that much, right? The stress on the column is not that much. So click on the close options to close that. See, all of the columns have been designed successfully. So the same way you design all other structural members of the structure successfully. Alright, so this is the right way to actually carry out this kind of complex modeling. Okay, for more complex modeling, you can join our ongoing training program, okay, which will teach you more complex modeling product structure. Don't forget to like and subscribe to our channel, Soft Reason. Thank you for staying through these presentations. And then, if there's any questions, you can always reach to me, okay, through our YouTube channel in the descriptions of this video, okay. So, the truss system that actually connect these two structures, that bridge these two structures together, this system is a private video, alright. So the next video we'll be considering is going to be the foundation. So you found the foundations design video on our channel, but this truss system is a private video, okay. So you have to get it download in the descriptions, just as you have done it, okay. That is why you're able to watch up to this point successfully, okay. But for the foundations and the stick connections, okay, we will do that successfully on our channel, YouTube channel successfully, okay. So doing foundation design of this steel bridge in this video. But before we proceed, I want you to get this book, Structural Foundation Designers Manual. It is free of charge, okay. Soft Reason channel have a group chat, WhatsApp group chat, okay, that you can just have to join to be able to access this book, okay. So the link for the group chat is in the description of this video. So check the description of the video and then join the group chat, and then you will see this book already posted in the group chat successfully. So let us proceed, okay. So we will be considering the foundation design successfully in this video. Here we go. So we are going to be considering buoyant type of foundation, okay. It is going to be a buoyant foundation design that is a floating raft, okay, or the another name for it is floating raft foundations. We're going to be designing using the finite element method of analysis to carry out the design, okay. And then we will explain the situations where this steel bridge is to be built across water, what we have to do, okay, to the foundations to make it more solid, all right. And then when it is to be built on land successfully, okay. So let's make progress. Before we proceed, we need to navigate to the story 0 radius. I will double click on story 0. Mind you, the Protastructure we're using is Protastructure version 2022. You can see over there, okay. So we get to the plan view of the foundations successfully, just like this. So now you can see the line of the setting out line, okay, from the line 3, grid line 1 right there at the setting out line, okay. So this grid line 7 and 8, okay, is being offsetted due to the foundation design, okay. So now it is being offsetted from grid line 3. Right click and click on the offset right there, move your hand this way, hold the shift F2 right there, okay, and then key in the distance. That is how this grid line 8 and 7 we are obtained successfully. So we proceed. At this point in time, we want to replacing the reinforced concrete slab. We are going to be considering, okay, for our floating raft foundation for this steel bridge successfully. So we get there to the modeling tab, click on the slab right there. So in the slab dialog, we need to do a few settings. The slab thickness we will be considering is going to be a slab thickness of 250, right, 250 millimeters slab thickness, okay. Then we will navigate to the load, okay, for the we'll use the lowered slab right there options, okay. So that will generate a simple weight of 6 kilonewton per square meters right there, as you can see, with respect to the unit weight of concrete successfully. For the dead load, additional dead load, we just applied 3 kilonewtons right there. And then for the imposed load, we will choose an imposed load of we can decide to use this one, okay, 7.5, okay, kilonewton imposed load. All right. So after which we start to place the slab successfully at this foundation level, but we may choose an insertion method. So you have to navigate to the general tab, and then you navigate to this provision, change it to pick axis or pick point. Any of this works fine, okay. So let's go by pick axis option. So we are going to be picking the axis that is bounded by the slab we are about to insert. So we choose the fork axis, which is axis F right there. Okay, after getting that selected, you see in the instructions provisions of this dialog, you can see the F right there being placed. So we'll choose axis H right there, axis A right there, and axis 7 right there. Okay, we'll go straight away to choose axis F to have our slab inserted just like this. You can see the same thing applicable here. So we have to get rid of the previous instructions axis, and then we'll start afresh from 9, and then we go ahead F right there. Okay, then 10, then A, and 9 again to have that insert successfully. So here we go. You can see if I shoot close this dialog and then I navigate to the 3D of this model, now you will see that we have our foundations. This is a raft. Okay, so although we have not designed it yet, but we will carry out design shortly. All right, so now if this structure is to be built on land, this is okay. This design is enough. Okay, if you have to build this structure on land, this foundation design is enough. Okay, except if there is any punching. If you are experiencing any punching, you can apply an additional footings under these columns provisions, or you can as well increase the thickness of the floating raft successfully so as to cater for the punching successfully. Okay, but if you have to construct this steel bridge across waterway, what you have to do is you need to provide an embankment. Okay, an embankment such as retaining wall around it. So what you do now, navigate the green lines to the story one. Okay, just like this, and then you can proceed to get to the plan view of the story one, straight away to the walls right there. Click right there on the wall. Okay, so in the wall dialog, you have to set the wall thickness right there. Right, so we go by this thickness, so you just have to place the wall just like this. Okay, so this wall now is going to serve as a returning wall. This is going to actually like a retaining wall, which is going to be preventing the water, seawater from intersecting with the foundations directly. Okay, so having placed this successfully, you need to also have an additional extension of the slab. Okay, so we will proceed to the slab provisions right there. Click on the slab right there, and then you come over to this the thickness of the slab we maintain 250. all right, and then get over to these provisions. We use lowered slab, and then we use 7.5. okay, after which come over to general, and then the type of slab is going to be this cantilever slab. So you will choose cantilever length of just 500 for sake of these presentations. Okay, after which you just have to start placing it. Mind you, we are not at the foundations right away, so we can place it here. We are story one, so you have to close this, or you navigate to the story 0 right here at the foundation. Here you proceed the same procedure, and then you have to also take note that at the foundations there is no way you can place a wall. Okay, so you don't place your wall while at the foundations using Protastructure. Okay, so now we proceed with the slab. Click right there. So we also have to set the slab thickness, and then over to the loadings you use lowered options, and then right click, and you will have to navigate to this value of imposed load, get over to the general, and then we choose this cantilever slab. Come over to these provisions. The length is going to be 500. Okay, just like this. If you want to apply an additional load, you can apply additional load here, but in this case we wouldn't apply any additional load. So to pick the first point, pick the second point, move your hand outward and place it. So the same thing in this other phase of this was successfully, and they have that. Okay, so the same thing applicable here, right? So this is how you actually provide support cantilever slabs to the wall successfully, just like this. Okay, so having done this, you can now navigate to the 3D. So at the 3D now, you have something of this kind. All right. So this is an options where you have to, construct this bridge across a waterway. Okay, this is recommended. Okay, so what you do after construction, all of these provisions have to be filled. Mind you, you have to take cognizance of the water level. Okay, water level, very, very important. You have to study that and ensure that this is being taken care of. All right, so at this point, we can now proceed to carry out the analysis. Okay, so the analysis, just as I said earlier, is going to be a finite element analysis. But by then, we have to run normal static analysis. Okay, so to run a normal static analysis, you use these options, and then for the FE, which is the finite elements, okay, we use this option. So before we proceed, we have to save this project. Click on the save options right here. So this has been saved successfully. Click on building analysis. We will run this analysis and observe analysis completed. Okay, so we proceed. Click in this options, analysis options, just like this, and then building analysis straight away. So this is going to pop up a dialog just like this. Okay, which requesting us whether we are to analyze and design at once. We just want to analyze, we will design our members later. Okay, so click on build analysis right there. So analysis have already started. Okay, so and this is a static analysis, as you can see over in this analysis type in these provisions. Okay, static analysis. So let's give the program some second to carry out this structural analysis successfully. Mind you, in the process, if you have any questions, you can drop it in the comment section as well. If you drop it in the group chat, okay, that will be more effective because various views will actually look at it and then give you what you actually wanted as answers to your questions successfully. Okay, so the link to join the group is in the description of this video. So analysis is completed successfully, but let's just wait for it to bring and pop up the final statement and message. Okay, so relative story draft satisfy limit. So everything is fine with this structure. Click on the OK options. Okay, after which, if you want to build this structure, maybe the analytical model of this structure, you can go to post analysis and then you can use this option to display analytical model. So once you click it, it will take you to the analytical interface. Okay, here you can actually check for your bend moment, your shear force, and the stress on the structure. Okay, depending on the dead load, depending on the life load, as well as the wind load if applied successfully. Okay, so here we go. This is the analytical model of this structure. So this is what we actually have, okay, as the analytical model right there. Okay, so you can check the animations of that. Okay, so you can now see, right? Okay, so we make progress. Now we proceed. Let's do this. So over here on this icon build analysis, you see it has been checked, okay, with green check right there. So for the FE foundation analysis, we still have a red cross, meaning that has not been done. So what we need to do, navigate to the story 0, okay, at this story 0 right there, okay, and you have to proceed to the plan view of that story so we can carry out the foundation design. Double click on the story 0. So here is the story 0. So we will carry out the FE foundation design right away. So what you have to do, click on this FE foundation design. So once click on that, okay, you will have all of this, okay, settings. So you can consider beam torsional stiffness. We didn't have beam in this structure, so you can uncheck these provisions. Okay, include column sections in FE model. Yes, we can go by that. It's not an issue. Okay, so we can as well look at your shared element. Okay, the sizes, we go by this, and then you click on the floor match and analysis. Okay, so Protastructure 2022 is actually being improved. Okay, it's been improved, unlike Protastructure 20 21 and then the lower versions. Okay, this has been improved, and then designing a finite element analysis process is now more easier. All right, so here we go. These are the structure and the foundations, okay, or the substructure of this steel bridge. Okay, so at this point, click on the OK options. So to have this perform analysis, click on the OK options. Okay, so analysis is being completed. Okay, so you can see over here. So what you need to do is to design, okay, the moment, the displacement, as well design and okay provide the area of steel successfully. To do that, you have to click on the display analytical model, these options. So click on these options. So having click on these options, you have this. Okay, so once you have this, okay, so you can see now this is the foundations of this structure. Okay, so we want to be designing this. For us to do that, you get over to the contour tab right there, the contour tab right there. So click on that tab, and then you have this contour. Use the user define contour, and then trace or contour. Okay, all of this has meaning. All right, but we'll be using the first options. Okay, so what we need to just have to click on the first options. So once you click on the first options, you can see the changes that we have in here. You can as well get this minimize so we can have enough provisions. All right, so now you can see the effect. So what we just have to be doing is to be clicking on the effect provisions. We will look at the displacement in the X, the Y. So you don't have to be clicking on that, and then with the help of this key right here, okay, so you can be able to know where the pressure is being intense, okay, on this foundation. So the Z direction displacement and also forces in the F 11, 22 and 12. Okay, so you have to also check that successfully. Okay, but what thing that is certain is that you wouldn't have to disturb yourself, but these are the things you are supposed to do. Moment, okay, in the local axis M1, M2 and M12 torsional moment. Okay, you check all of that, and then design moment using wood and armor. Okay, you have to also check that at the required steel area. Okay, in the local axis, direction 1, direction 2. Okay, and then top direction 1 and direction 2 as well. Okay, so these are the things that are necessary for us to carry out, and the required steel area using wood and armor. So while you are clicking on this, if this section is insufficient, it will actually pop up and then let you know that the sections of the raft slab is insufficient. All right, but we wouldn't have that because our section is sufficient. We are not experiencing any punching. Okay, so after we also check the soil pressure. So soil pressure simply means if the soil is weak at any point, it will actually show us, right? But everything is quite very all right with what we are doing right away. So what we have to do is we just have to navigate back to the physical model since we are done with the analytical effect of a finite element method successfully. So we get back to the physical model, click right there. So this get us here. Okay, so the next thing we will do is to generate reinforcement for the foundations. Okay, for us to do that, we will get straight away to the modeling tab, and then okay, just first confirm that FE foundation analysis has been checked. Green check right there, meaning it's being carried out. Okay, so get back to the modeling tab, and then slab strips right there. So in the slab strip dialog, I want to show you something important here. Okay, so the first thing in the general tab right there, you see the arrow, which is directions 1, directions X and Y right there. Okay, these are the numbers of strips. Okay, so as you are drawing the strips, it will be showing right here. Okay, then we come over to the type, okay, of strips. We have the analytical strips right there. We wouldn't use that, we use FE strips right there, and then use this option to fixed band strips options. This one we will be using. So we are in the X direction, so we have to select any point right there. Take your hand across the reinforced concrete slab foundations, and then hold the control key to have a straight line. Click to just have the bounds, okay, being placed successfully. All right, just like this. Okay, so you see it doesn't take the whole area of the slab, but what we need to do, we can adjust it. So just click on this small arrow sign right there, this point where my cursor is, and then pick the edge of this slab. Click on update to move the line to that edge. Successfully pick that point again over to this side. Right, just like this. So we are okay with that. The same thing, we are in the same direction X, so we have it also in this provisions. Click right there to have it placed, and then use these options to adjust that. Successfully update right there. Okay, the same thing over to this side and update. All right, after which we move to the direction Y in the vertical direction. So pick a point right here. So having placed that successfully, let me show us something. You will notice that our reinforcement has been drawn successfully. So we are having reinforcement running top and bottom right there. So it is Y10 diameters of rebars, okay, at spacing to 200, okay, right there, both top and bottom. You can now see being generated successfully right there. Okay, so the same thing we are going to be doing in the vertical directions. So we have this successfully, so you can use the split bound options to actually shift and adjust that successfully to fit in line with the area bounded by the floating raft foundation successfully. Pick this point and then all the way up right there and place your hand right there. Okay, so use these options again, pick there, okay, and update, and then pick this point again. All right, sorry, escape that, pick this and that point, update. So you have this. So you're now having array bars. Okay, so you can close this right away. We are done with the strips. Okay, so we have array bars. You can now see it with rebar running in the directions and the direction. So this foundation has been designed successfully. All right, so you can now navigate to the 3D and then you see what you've done so far. So you have something of this kind. Okay, so how about the reinforced concrete columns? We can't go into designing that right away. So we need to navigate to the story one, expand this. You can see it is showing a kind of a nullified analysis, sign, having this gray sign right there. So you have to use these options over to this dialog where you can carry out the interactive design using the bash mode. So as well, the shower having generated reinforcements as well. So you use this bash mode column design. So and then we select all back to calculate. Okay, so give the program some circles, and then this is going to carry out the design and generate reinforcement for all of the structural members. So it is completed successfully. Click on the close, and then have everything been designed successfully, just like this. Okay, so click on the close options. Okay, so you will see we are able to carry out the foundations design of this structure successfully. If you wouldn't understand or you need any question, you can drop it in the comment sections as well. You can join the group, okay, the group chat, okay, the link in the description of this video, so you can also ask questions right in the group and then be able to get or access this book as well. Okay, so hello and welcome. In this video we will be considering connection design of the members that consist of this steel bridge successfully, just like this. So we have the base plate and then this access steps right there, as well as the railing and other connections, just the way you are seeing will be considering in this presentation. Let us get started. Then let me close this. Okay, so we navigate to the drawings and report tab right there, and then you click on Protastructure so as to move the model from the interface to Protastructure interface. But before you do that, you have to make sure the model is being analyzed and designed successfully. So you see in the building analysis icon right there, have a green check, meaning this model has been analyzed. You get back to drawing and report. Click on Protastructure just once. Give it some time. It is going to load and transfer all of this model to Protastructure model, where we carry out all the necessary connections of this steel bridge successfully. You close this, and here is the project. We proceed from here. Okay, so at first we will be looking at the base plate connection. Mind you, if you have not joined our group chat, you can see the link in the description of this video. Okay, so for the base plate connections, you come over to base plate connections. So you see various base plates right here with stiffener. Okay, this can be set successfully. Okay, so you just click once on it. So after you click once on it, you click on the station. So it's going to be placed successfully, just like this. All right, so I have already set this successfully. Okay, so most of these designs are being done in our master class. Okay, the settings are being done in our master class. So I advise you to join our master class as well, so you enjoy all of this and how to get this done effectively. So after which you can just have to get to the miscellaneous, where you have the anchor bolt. So just click once, right click, then select the plate to have the anchor bolt in place. Just you can see. So this is what is going to happen to this other base plate and the rest of the pedestals. Okay, so as to connect the stations successfully to the pedestal. But for this one, it is going to be manual. All right, we'll manually model this. Okay, successfully. All right, so let's proceed for other connections. So the next one I would like us to consider is the access steps. Okay, so for the access steps, you will navigate to where you have provisions of detailings. Okay, so once you got here, you see stringer. So just click on it once. You pick the first stringer and the second one to have the access steps. So the same thing is applicable here. Okay, so this is not can see. All right, so this is how you place the access steps, okay, to these platforms successfully. So the same thing will be applicable in both sides. All right, I really want this video to take longer time, so I will have to also just to show you how you can carry out some of these connections successfulully, and then we proceed. Okay, then for the railing, you can't come to this auxiliary steel work. Okay, so you see a railing there and rail, so click on it once, and then you have to select the members you want to actually insert the rail on. So select these members, and then you right click, you can pick the first point, okay, and then the second point to define the length of the rail. So you have something like this, so you can proceed to place your rail just like this. Okay, you can see. All right, so that is how you can as well placed rail successfully. The next thing we'll look at is the we will look at the fin plate connections. Okay, how to connect these steel members successfully. Okay, the stanchions and as well as the beams successfully. For you to do that, you will have to navigate to, depending on what you are connecting. Okay, so there is a connections for beam to beams, okay, and also beam to column connections. All right, so for instance, we want to get this connected columns and this beam connected successfully. What you need to do, you get to the beam to column connections options, and then you can try some of this connection. Anyone that is suitable, you can use successfully. For instance, fin plate, these options, I can pick that, right, and then I will select the stanchion first, and then select the beam stringer. So after which I have to right click to activate the connections. Okay, so you can see it's been connected successfully, just like this. You can see, right? So the same thing is applicable to other connections, like let's connect this steel stanchion to this beam. Okay, so we also used this particular connections, or let's change it to this one. So if you pick that, you can easily select the stanchion, okay, because that is the primary members and this is the secondary members. Right click to insert it. Okay, So you can see it right there. So the same thing is applicable. You can also use this beam to beams angle clipped, okay, for this particular connections as well. Okay, for instance, if I update this way, right over here, I can use this as well. So I pick this, select this and this one, right click, see it's being connected successfully. So let's see right there. Okay, so here we go. So for this one, see this connection right here. Okay, film plate can work here successfully. All right, also in these provisions, film plate will be perfect. Okay, in these provisions. So if you want to proceed, you can also check this. Okay, this is film plate beam 2 beam. Okay, so and then we have also film plate, okay, columns 2 beam. All right, so we can use any of these two in these provisions and they will work fine. For instance, I pick this, select this beam right there, and I select this one. I right click right there to insert the connection. So you can see it's been inserted successfully, just like this, and modeled. Okay, so we proceed for other steps. Okay, we will navigate back to the detailing options, these options right here. So always just select this once with the two stringers, okay, to have that. Okay, select placed successfully. You can see, right? So the same thing applicable here. You pick the stringer hose, pick this two, place that. Okay, so having placed this, you can also proceed with the railing. Okay, proceed with the railing. So pick the railing, select the members, next one. So we'll start from this point up to this point right there to have the railing right there. Okay, so it's something applicable here. Okay, and then you proceed for the railing insertion. Okay, so this is not correct, so select the macro, right click and delete that off. Yes, options. Okay, then you insert that again. Make sure pick the right 2 points to have this. Okay, so now if you check in this railing this elbow provisions, what you do, you use this Android connection. So just select that, this one and this one, then you see it being connected like this. Okay, so proceed to place the railing successfully. Pick this one, select this, right click and pick first point all the way, second point. Use the Android connections, have a good elbow. Okay, so this is what you get. All right, so after which the next thing is to look at this part of this bridge successfully. For this part of this bridge, what you do is you see this these two members connections. All right, what you have to do, you need to navigate to where you have brace connections. Okay, truss. Okay, truss connection. This. Okay, so select this. We want to use welded pipe. Okay, so after we select this beam and then select this pipe, right click, right, so see, you can see it welded successfully. Very modern. You can now see it's being welded successfully. All right, so this is what you do to all of the pipes successfully. Okay, and as well for these connections, okay, you can get to beam to column connections and see how to carry out that successfully. This is beam to column connections successfully. Okay, or you can as well proceed to truss connection. So since this is a truss system, we can use also these connections right here, or we can use this one. Okay, any of these two connections may work effectively right here. Okay, so we can use this welded pipe for the top chord of the truss system. So just select it right there, pick this stanchion and then the beam, then right click, So this has cut this beam. So you can now see how it trims and welded it to this column successfully. So the auxiliary micros right there, you can always select this provision to get rid of that. So you can see how modern this is now. Okay, in this end. Okay, so for this one we can still use the same method, which is this and this. All right, so if you do this now, you can see it's been trimmed and welded successfully, but this is not I think this may not be that stronger. Okay, so we may choose to use this truss end plate. Okay, truss end plate with gusset provisions right there. So if I undo this right there, I can pick this one and then select this and this one. I click and then I have something of this kind, right, which we now need us to provide some additional provisions in order for us to have this board, okay, being boarded successfully to the stanchions. And then I believe with these connections and this one, okay, this part of the bridge can be, solid in terms of stability, right? So the same process you use in all of these provisions, okay, to be able to get the all connections done successfully. Okay, we have carried out some of these connections successfully, as you can see. All right, so if you want to have a kind of a castrated steel castrated steel members, you will have to come to the detailing tab, these provisions, detailing. Okay, so for the castrated, you will just have to click on this. So it all depends whether you want the castrated with stiffener. So you can see the multiple stiffened webbed opening. So we can select right there to create that successful, as you can see. So just like this. Okay, so if you really want it with a stiffener, you can just have to right click on these provisions and then you have this. Okay, so once you have this, you can be able to look at the placement and as well as the geometry. Okay, and then the stiffeners. So if you really want to have a stiffener plate, so you can also make provisions here to get rid of the stiffeners successfully. Okay, so after you must have done with your settings right here, you click on the OK and then proceed. So that is how you can actually be able to, create a castrated steel member just like this. Okay, then the other things are the base plate, which I've explained earlier. I will also proceed to actually insert more of the base plate. So you select this and then select these distances to have that just like this. Okay, just as I said earlier, sorry, that's a mistake. So pick that point, that one. Okay, as I said earlier, we are going to be modeling this. Okay, this particular one. So I will throw no light on how you can model a kind of base plate here. Okay, in a minute. Okay, so the same thing, just have to place these ones successfully, right? So after which you can as well give it an anchor bolt, which is the same process. Okay, so select this and then right click here to insert that. Select this, right click on this to insert that successfully. Now I want to throw more light on how you can actually design a base plate for an inclined beam on top of a pedestal just like this. So what you did is the plate, so you just have to select the plate and then you just pick the four edges of the pedestal to first place the first plate just like this. Okay, so now as you can see right here, you see that this plate is being embedded. You can use Control W, okay, to take it up or take it down. Alright, so this inclined stringer is supposed to sit directly on the plate successfully, but you can see that the plate itself is being embedded inside of this pedestal, so you have to do some cuttings. Alright, okay, so for some cuttings, if you want to do a cutting, you have to go to Edit tab and then you can see polygon cut right there, so you can pick that one. Okay, so the depth of cut you can just use let's say 500 right here. Okay, so and then use general, so you need to select part and point. Okay, so the part you want to cut, so this option, click on it right there. The part is the pedestal, so select the pedestal. So the point you want to cut actually, so you have to define it. So I pick that first point just like this. So you define the part you want to cut. Okay, all right, so you can see this has been cut successfully. So now that you have cut this, you will notice that the depth of cut we entered only ends somewhere here, so it does not cut the whole of the pedestals that have this plate embedded successfully. So what you do, just have to undo, right? Okay, get to cut again. This time around, don't use 500. Let's go by 1000 millimeters depth of cut. Select that, select the pedestal. Okay, pick this first point, second point. Just as I said earlier, you will learn more of this in our masterclass successfully. Okay, so you can now see that we have cut this successfully. Okay, so having cut this, you can proceed to wet the stringer, glass stringer to the place successfully, or you can proceed to start to place a bolt, okay, on it. Okay, so to place a bolt on it, it depends on the numbers of bolt, the position of bolt that you actually want it to placed, okay, successfully. So after placing the plate, you can see you create a holes on the plate. It all depends on the numbers of bolt you want to have. Okay, for the sake of this video, I've created about altogether 6 holes. Alright, so now there's no need creating it in these provisions. I can just copy this to that point. What do? I have to go to edit right there. So you can see copy right there. So you can select, right? So, then use copy by entering distance, copy by selecting 2 points. So we use the options. So I want to pick it from this point. I want to pick it actually from this point. Okay, or to this point. But before then, I have to activate this micros. Okay, the cut auxiliary micros. Okay, after which I will get everything selected, both the cut auxiliary micros and the plate right there, just like this. And then I use the by 2 points cuts. Okay, so I pick that the top most edge of this plate, just like this, all the way to this point, placed it right there. So you can see what is happening right there. If I deactivate this cut micros, you see, so we still have it just like this. Okay, so you can now see, if you want to place the anchor bolt right there, pick the anchor bolt, right click right there, select this plate to insert it just like this. You can see, right? So this is how it works. All right, so you can as well do the same thing here. The anchor bolt, click, place it right, like this. You can see, so this is how you provide a kind of anchor bolt for an inclined stringer like this. Okay, so you can, it depends, you can choose 2 of this bolt, or you can as well choose 3 of this successfully. All right, so if you have any question, you can drop it in the comment sections right there, and as well you can join our group chat and be able to ask any questions that is bothering you in the group chat. The link is in the descriptions of this video. Alright, so I wouldn't mind like to repeat this. Just go copy from here to this other side, copy from, just have to just copy, alright, and you get everything done. Copy this to this other end, okay, and use it as well. Okay, so this is all we have covered in these presentations. Okay, I will also advise and invite you to join our masterclass, okay, in Protastructure and concrete designs. Okay, we'll stop here and see you in the next presentation. Stay safe and stay connected. God bless you. Bye for now.